Hi everyone, today we are going to present on our assignment for electromagnetic field theory with the title of Ampere law, magnetic field around a variable resistor. First of all, we set up the apparatus as below. The apparatus and material needed for this experiment is ohmmeter, variable resistor, ammeter, magnetometer, ruler, wire, and power supply. To make sure the functionality of magnetometer, we place the magnetometer beside the variable resistor. When power supply turned on, we notice that the magnetic field increased. First, adjust the variable resistor to 25 ohm. We increase the distance between magnetometer and variable resistor from 0 cm to 5 cm, 10 cm, 15 cm, and 20 cm. The magnetic field is measured and recorded. Repeat the experiment by changing the resistance to 51 ohm. Change the distance from 0 cm to 5 cm, 10 cm, 15 cm, and 20 cm. Next, change the resistance to 75 ohm. Increase the distance from 0 cm to 5 cm, 10 cm, 15 cm, and 20 cm. Next, change the resistance to 100 ohm. Increase the distance from 0 cm to 5 cm, 10 cm, 15 cm, and 20 cm.
Now, let us have a look at the result of our experiment, where we explore the magnetic field produced by a current flowing through circuit with a rheostat and measure the magnetic field strength at varying distance. Unlike traditional experiment using a current carrying wire, we use the rheostat to control the resistance in the circuit and adjust the current. A rheostat is a variable resistor that allows us to control the current by adjusting the resistance. By changing the resistance, we can vary the current and observe how this affects the strength of the magnetic field. According to Ampere's law, the magnetic field is directly proportional to the current, so as we reduce the resistance, the current increases, which should also increase the magnetic field strength. In addition to adjusting the resistance, we also change the distance of magnetometer from the stick. As expected, the magnetic field strength decreases as we increase the distance, which supports Ampere's law. This inverse relationship between magnetic field strength and distance confirms that the field weakens as the magnetometer moves further from the source. However, there was an interesting anomaly at 20 cm, where the magnetic field strength increased again. Upon reviewing the data, we conclude that this increase is due to the shift in direction of the magnetic field. The magnetometer shows a negative compass reading at this point, indicating that the direction of the magnetic field had reversed. This could have been influenced by a change in the current, which was adjusted by the rheostat, possibly causing the magnetic field to switch direction at that specific distance. In conclusion, the experiment successfully confirmed Ampere's law, showing a direct relationship between the magnetic field and the current, and an inverse relationship between the magnetic field and the distance. The anomaly at 20 cm was likely due to a shift in magnetic field direction as detected by the change in the magnetometer reading.
This part explaining about the graph obtained from our experiment. Firstly, these two graphs shows the magnetic field against current. We change the value of current by changing the variable resistor. It is reversely proportional between current and resistance. So, once we increase the value of the resistor, and we will get a lower value of current. In this case, at a fixed distance, we're changing the current value. From the graph, we can observe it is a directly proportional relationship between magnetic field and current, and it is clearly verified the formula of the magnetic field will increase due to the increasement of current. Next, these two graphs explaining the relationship between magnetic field and distance. As we can see, when it is applied by a fixed current, the magnetic field will decrease if the distance increases, and it verified inversely proportional relationship between magnetic field and distance.
The experiment finding confirm Ampere law, as they show an inverse relation as predicted between the strength of the magnetic field and the distance at which the wire is played radially. The strength of the magnetic field increased with the rise in current, confirming Ampere's observation that the magnetic field is directly proportional to the current. The strength of the magnetic field was also recorded to be declining when it has a longer distance away with the wire.
That's all from us. Thank you.